Hi everyone. So this part of the section in section 8, we're going to be looking at 4 different types of reactions that you would have covered in grade 10 science. So we're going to be looking at synthesis, decomposition, single displacement, and double displacement. So they should look and sound fairly familiar to you. We're just going to go in a little bit more detail on every one of them. So the other thing is every one of your notes is basically going to be formatted exactly the same. So the first little bit of every note will be a description as to what the reaction actually is. And then the other part will be keys to recognizing it, because what will happen on a regular test is I would give you a list of reactions, and then I would just say, hey, which one is a synthesis reaction, which one's a decomp, which one's single displacement, or which one's double displacement. If you want practice on that, take the balancing chemical equation worksheet that you guys just finished up, and on that, see which ones you can recognize and as synthesis, which ones you can recognize as decomposition, single displacement, and double displacement, and that'll get you good practice for that. Not everyone is going to be one of the 4, but you should be able to recognize that. And then the most difficult part in this section will be predicting the products. So what will happen is I will tell you, hey, this is a synthesis reaction. These are your reactants. What are you going to make? So that'll be the most difficult part. So make sure you pay attention to that when we're doing the note, okay? Ciao.
Okay, so the synthesis reaction, there's kind of a famous dance analogy that goes along with all of these reactions. So think of a synthesis reaction as 2 single people, and then they're joining together to make a couple to do a slow dance. So that's kind of what a synthesis reaction is. And again, the hardest part is coming up with predicting the products. So I'll go through a couple of examples for you. So let's say we had magnesium and it's going to react with oxygen. And we know it's a synthesis reaction. Well, what is it going to make? Well, we know it's going to make one thing, okay? It's going to make a compound. And remember that magnesium has a positive valence and oxygen has a negative valence. So magnesium will generally react first. So if you happen to see oxygen plus magnesium, when you put it together, magnesium still has to go first. Now, I find it's actually easier to predict the product using chemical formulas. And I'll show you that. So when I am doing this one, I know magnesium and oxygen are going to go together, okay? Now, when you're doing this, whenever you make a formula, unless you know the formula, you need to look up their valences. So magnesium is +2 and oxygen is -2. So when you crisscross, the 2's are actually going to cancel, okay? So you'll get MgO. And now, if you know your nomenclature, now you can go back and finish the word equation. The word equation is going to be magnesium oxide. And that's how you would predict the product for something like that. If you had something like this, let's go with, let's go aluminum plus oxygen. Now, it's going to be an oxide, okay? Again, I find it easier, and by easier, probably less thinking, to know that aluminum and oxygen are going to go together. Aluminum's valence is +3, oxygen is -2, and then this is where the crisscross comes into play, okay? This is going to go right there, and this one is going to go on the other side. So when I crisscross, I'm going to get Al2O3. And then there's your skeleton equation. And then if you wanted to balance this, 2, 3, and a 4. To finish the word equation, this would become aluminum oxide. Okay, let's try this one. Let's go iron is going to react with chlorine, what is it going to make? Well, again, Fe, and then chlorine is Cl2. It's one of what I call the bloody seven. And then again, I know this is synthesis, so iron and chlorine are going to be together. Now, iron has two valences. It has a valence of +2 and +3, and then chlorine is -1. So when I am crisscrossing, the 1 is going to go right there. I have to pick between these. Now, there are more common valences than others, but for grade 11 chemistry, that's way above your pay grade. You would just pick one of these two. Most people will pick the one that's easiest to balance, but it really doesn't matter. So I'm going to pick the +2 valence. So that would give me FeCl2. Now notice what I did there. I did this. I simply didn't take the iron and the chlorine and shove them together to get this FeCl2. Symbol, symbol, valence, valence, crisscross. And now when I name it, I have to go iron to chloride. If you like using the Oshik system, then this would be ferrous chloride. And either one would work. So that's the tricky part on this, okay? Give you one more example of this type, where a metal and a non-metal making a binary compound. So let's go with sodium is going to react with nitrogen. Again, sodium is Na. Nitrogen happens to be N2. They're going to go together. So sodium and nitrogen are going to form a couple. They're going to slow dance together. Sodium has a valence of +1. Nitrogen has a whole bunch of valences, +3, +5. They're all irrelevant. When nitrogen is second, it has to have a negative valence. So now when I crisscross, this 3 is going to go right there, and the 1 is going to go on the other side of nitrogen. So that is going to give me Na3N. And then now I can hit the name of this. This is going to be sodium nitride. And then we just have to balance this. So if I put a 2 there to make the nitrogens balanced, 6 sodiums, and that would be a 6. And then that would be balanced. Eventually, you guys will be balancing this without an inventory. Not quite yet, but as soon as we're done section 8, then I take the reins off and then I just say balance it, and you don't have to show an inventory anymore. Okay, now you're going to notice that the last two are incredibly difficult to do. This one is where you have a non-metallic oxide and you're reacting it with water. So that would be something like if you took carbon dioxide and you reacted it with water. Now, we actually did this in section 3, if you think way back when we did the reaction of the elements in oxygen. When we burned carbon in oxygen, we produced carbon dioxide. And then remember, we shook the bottle and we basically reacted it with this. Now this is going to produce an acid, and this is going to produce carbonic acid. Okay. If we took sulfur dioxide and reacted that with water, we would produce sulfurous acid. Now, if you're like, well, how do you know these formulas? Remember, we did this in nomenclature, and those are the valences for that. If we took sulfur trioxide and reacted it with water, we would get sulfuric acid. That's +1, and this is -2. Now, if you haven't figured this out yet, we're starting with 3 oxygens, we end up with 4. We started with 2 oxygens, you end up with 3. You start with 2, you end up with 3. One other one, nitrogen dioxide, when it reacts with water, it would produce nitric acid. Start with 2, you end with 3, okay? And then again, this is +1 and this is -1. This is actually a main component in acid rain. So these are examples of a non-metallic oxide reacting with water. This is one I would tell you to put a star by. If we were having a test, these are the ones that there's no chance that you're going to get this, even if I told you it's a synthesis reaction, unless you pay attention to it. They're incredibly difficult. Now, the other one in your note is if you have a metallic oxide and reacting with water. Okay, so all of these are forming acids. And you'll notice that that was actually one of the answers to your questions for the lab in section 3. So let's say we took magnesium, we reacted it with oxygen, we got magnesium oxide. We're going to react it with water. We are going to produce a base, and the base is going to be with a hydroxide. +2, -1. When we crisscross, we're going to get magnesium hydroxide. And we're putting brackets around the polyatomic ion, or the radical, because we have more than one of them. Okay, you also did sodium oxide. We burned sodium and oxygen, produced sodium oxide. If that reacted with water, you are going to produce a hydroxide again. Sodium is +1, hydroxide is -1. We crisscross, we're going to get NaOH. Now, of course, you got to balance this, right? Gosh, let's go with, remember, these have to be metallic oxides. So if we did potassium, or potassium oxide and reacting it with water, we're going to get a base again. Potassium is going to be dancing with hydroxide. +1, -1. Crisscross, you're going to get KOH. And then, so all of these are all bases. So these are the two examples that make this incredibly difficult to do. You're not going to get a lot of these on the test. You would get mostly either an element reacting with an oxygen to produce an oxide, or you'll get the standard two elements mixing together to make a binary compound. Okay? So that's it. Good luck on the questions.